The fuel pressure regulator, or FPR, maintains optimal fuel pressure for your engine's fuel injection system. Located on the fuel rail or in the fuel pump assembly, it regulates fuel flow, preventing overpressurization or fuel starvation. Maintaining between 30 to 60 psi is critical. Without it, the car will not run as efficiently or may not even run at all. This regulator is a key component in the fuel system, ensuring consistent performance. Common signs of a failing fuel pressure regulator include several noticeable symptoms that affect your vehicle's performance. One of the first signs is hard starting, where the engine struggles to turn over, especially when cold. The engine may experience rough idle, shaking, or vibrating while at a stop. Sudden engine stalling can occur, particularly during acceleration or at low speeds. You may notice reduced acceleration, with the vehicle feeling sluggish when accelerating. Black exhaust smoke indicates a rich mixture, meaning too much fuel is being burned. Strong fuel odors or visible leaks around the engine bay are warning signs. The check engine light may come on, indicating a fault in the fuel system. These symptoms often stem from fuel pressure drops below 30 psi or spikes over 80 psi, disrupting proper engine function. The main causes of fuel pressure regulator failure include wear from age, leading to diaphragm cracks, clogged filter screens from contaminated fuel, vacuum leaks, electrical faults in electric FPRs, and ethanol blends accelerating corrosion. Wear from age is the most common cause, where the diaphragm cracks after years of use. Contaminated fuel can clog the filter screens inside the regulator, blocking fuel flow. Vacuum leaks often occur in the connecting hoses, causing improper pressure regulation. Electrical faults in electric fuel pressure regulators can stem from wiring problems or sensor failures. Ethanol blends like E10 accelerate corrosion of metal components, posing a growing problem. Diagnosing a bad fuel pressure regulator starts with visual inspections. Begin by checking vacuum lines and fuel lines for any signs of damage, cracks, or leaks. This includes looking under the vehicle for loose connections or worn hoses. Next, use a fuel pressure gauge to measure the fuel pressure at the fuel rail. Connect the gauge properly and start the engine to get an accurate reading. Compare this to your vehicle's OEM specifications, which are usually between 30 and 60 psi for most cars. For modern vehicles built after 2015, check for OBD2 diagnostic codes using a scanner. Code P087 indicates fuel rail pressure is too low, while P8 shows pressure is too high. These codes point directly to regulator problems. If you're comfortable with DIY repairs, start by inspecting vacuum lines and fuel lines for cracks, loose connections, or signs of fuel leaks. If the fuel pressure regulator is faulty, replace it with a new part that typically costs between $50 and $200. Also, clean or replace the fuel filter, which usually costs $20 to $50 and helps prevent contaminants from causing issues. For safety reasons, it's recommended to have a professional mechanic take a look at the fuel system to ensure proper installation and avoid potential hazards. Professional mechanics excel at accurately diagnosing fuel pressure regulator issues using advanced tools and onboard diagnostics. They conduct thorough repairs that may involve flushing the entire fuel system to eliminate debris and ensure proper function. Ignoring FPR problems can escalate to costly repairs, such as needing a complete fuel pump replacement. Expect average costs for these professional fixes to be between $300 and $600. To extend the life of your FPR, use high-quality fuel and fuel additives to minimize deposits. Regularly inspect vacuum hoses. For hybrid vehicles, FPRs now incorporate sensors for real-time adjustments, reducing failures. Stainless steel diaphragms are also becoming more common for better corrosion resistance. With the rise of electric vehicles, FPR expertise is shifting towards hybrid diagnostics. Hybrid vehicles combine traditional fuel systems with electric components, requiring specialized FPR knowledge for optimal performance. However, legacy ICE vehicles will continue to require FPR maintenance. Future trends include AI-driven predictive maintenance, potentially eliminating FPR issues in new vehicles through smart monitoring and early detection. Sustainability efforts also focus on recyclable FPR components to reduce environmental impact.